What exactly does iterable mean in Python? Why isn't my object which implements __getItem__ an iterable? First I want to clarify, I'm not asking what is iterator. This is how the term iterable is defined in Python's doc. Iterably, an object capable of returning its members one at a time. Examples of iterables include all sequence types, such as list, str, and tuple, and some non-sequence types like dict, file objects, and objects of any classes you define with an __iter__ or __getItem__ method. Iterables can be used in a for loop and in many other places where a sequence is needed, zip, map. When an iterable object is passed as an argument to the built-in function iter, it returns an iterator for the object. This iterator is good for one pass over the set of values. When using iterables, it is usually not necessary to call iter, or deal with iterator objects yourself. The for statement does that automatically for you, creating a temporary unnamed variable to hold the iterator for the duration of the loop. See also iterator, sequence, and generator. As other people suggested, using isInstance, collections.iterable, is the most Pythonic way to check if an object is iterable. So I did some test with Python 3.4.3. The result is quite strange. My train has defined __getItem__ method, but it is not considered as an iterable object, not to mention it's capable of returning one number at a time. Then I removed __getItem__ and added the __iter__ method. It is now considered as a true iterable object in spite of it cannot produce anything while iterating. So did I misunderstand something, or is the documentation incorrect?
I think the point of confusion here is that, although implementing __getItem__ does allow you to iterate over an object, it isn't part of the interface defined by iterable. The abstract base classes allow a form of virtual subclassing, where classes that implement the specified methods, in the case of iterable, only __iter___ are considered by isInstance and isubclass to be subclasses of the ABCs even if they don't explicitly inherit from them. It doesn't check whether the method implementation actually works, though, just whether or not it's provided. For more information, see PEP 3119, which introduced ABCs. Using isInstance, collections.iterable, is the most Pythonic way to check if an object is iterable. I disagree. I would use duck typing and just attempt to iterate over the object. If the object isn't iterable, a type error will be raised, which you can catch in your function if you want to deal with non-iterable inputs, or allow to percolate up to the caller if not. This completely sidesteps how the object has decided to implement iteration, and just finds out whether or not it does at the most appropriate time. To add a little more, I think the docs you've quoted are slightly misleading. To quote the iter docs, which perhaps clear this up. Object must be a collection object which supports the iteration protocol, the __iter__ method, or it must support the sequence protocol, the __getItem__ method with integer arguments starting at 0. This makes it clear that, although both protocols make the object iterable, only one is the actual iteration protocol, and it is this that isInstance, thing, iterable, tests for. Therefore we could conclude that one way to check for things you can iterate over, in the most general case would be. Although this does also require you to implement __len__ along with __getItem__ to virtually subclass sequence.
It is an iterable. However, you haven't inherited from abc.iterable, so naturally Python won't report it as being descended from that class. The two things, being an iterable, and descending from that base class, quite separate.
If you want to support the channel, please consider liking and subscribing.